So what's common about those three platforms, excuse me, is that they are all designed and manufactured digitally. So they're done in a 3D, the 3D design tool, the digital mock-up. In the case of the Airbus, they actually fly it digitally before they even build it. They have an underlying, what we call product lifecycle management platform, which we're calling now BLM for your industry, or for our industry, I've got to call it now. Building lifecycle management. And that's all I want to say about those three items. Excellent. So this is what I want to run through. So my main focus is to talk about what's happened in aerospace and automotive and the transformations that may apply, and also talk a little bit about what we see building lifecycle management is. I think in the last, what I'm seeing now is there's a lot of software platforms available that are now talking about collaboration, which is great. So you've got a choice. There's no doubt in my mind that that's where we're headed as I learn how to drive this thing. I'll get there, promise. So I work for a technology company. Right. Good. Great. Context. So I'm not here to talk about MEMKO and Dassault, but I feel the context is important. So like I said, my job is to bring, Dassault Systems has an office in Melbourne, but they support partners where they're partner for AEC. A lot of people haven't heard of Dassault Systems, and so I usually like to start with, have you heard of Gehry Technologies? Have you heard of Frank Gehry? So while Dassault was building a better CATIA, which is a design tool, or a better, Inovia PLM, 20 years ago, Frank Gehry grabbed CATIA and started himself building out the parametric modelling and the knowledgeware that will enable him to design these funky pieces of facade and then be able to construct them in a way that was cost effective. So usually that gets me, 50% of people go, yeah, I know what you're talking about. So the other 50 still don't. They're a scientific organisation. They are still keen on developing software. It's up to people like Frank and us then to take that software, configure it and take it to market. Probably about 5 years ago, they figured out that they need to do that themselves. So they introduced these industry teams that are from the industry. Some of you may have met the guys that came out from the US earlier this year to speak at RTC. So now they've started to figure out they need to change and provide software applications that are manageable, affordable, sit in the cloud, all of that sort of stuff. The other thing they do is they work with, they like to select companies that are well-known, global companies, and they'll actually offer to develop the software with those companies to get more of that industry experience. So they do that a lot. We're an engineering services business. The business was started by a guy who's an aviation engineer, and he spent 20 years at Boeing. So we're sort of, I guess, well equipped to tell a story about aviation and aerospace. We have about 12 engineers, and we have one of them now training as an architect. So we are, I think we do understand engineering, just not all of it related to this industry. So we're now transforming ourselves to be able to, we need to have credibility. We need to be able to speak the same language. So Alex, I couldn't resist. I decided I had to pull some of these slides up. Right. I'm more critical of our own government than the actual, I met a lot of really clever people in the industry that are in the process of transforming, but seriously, we have to change what we're doing, and we have to be more cost effective and more productive. And I think you've all seen these, right? I think everyone's seen these and sick of them, so I'm actually going to flick through them fairly quickly. Prefabrication's an interesting conversation. In my mind, again, out and about talking to people, I'm not sure the conversation's about prefabrication. It's about, well, you have the life cycle of a project. Some of the things Alex was talking about. How do you go from design through to completion in a way that's more effective? So, but there's no doubt, and this is the experience of aerospace and automotive, there's no doubt that there are major benefits to be obtained by starting to look at how, and we already do it, right? I mean, there's a lot of systems in a building now that are brought in in a prefabricated sort of manner. So maybe it's a case of just improving that or accelerating that. Interesting again, talking to different players, how we're all siloed. Probably the guys, I don't know, this is just strange for me because what I see happening is that there's a lot of cost pressure, there's a lot of quality pressure, and the risk and the cost seems to be just continually pushed down. And I think it's again, I'm a newbie, but the head contractors and the owners need to step up, and the ones that need to get in early in this process, like our friend from the USA who spoke from the owner community. That was refreshing. And it's going to take time to transform, but just to have the vision. I'm going backwards again. I love this. See, this is applied to every industry I've worked in. So I apologise if you've seen it, but your ability to impact is obviously early in the process. If you're trying to change whether a submarine will submerge at this stage, you've got a problem, right? The Airbus A380 used two different design tools. And when they came to bring it together, they were literally, this is a true story, and I can't remember the exact measurement, but it's like a foot short on some of the wiring. Cost them a year, right? So there's got to be a lot more done at the start of the process collaboratively to improve the way we go about things. That's pretty obvious. You can see I really like these charts because I've got another one. And this one we've all heard of, right? MSC. Actually, I don't know what it is. I just did it for fun. I have no idea what this is. But this one I can relate to because that's what I did during university when I worked on projects. So I do have some experience in the industry, I guess. In terms of aerospace and automotive, which is, I guess, one of the main parts of the presentation. So they've gone through, what I have noticed again out and about and just this morning, is it does take time to implement change. So that's a good thing. And aerospace has been through it. So if I break these down, so in the 1950s you had your 2D design, 2D drawings, then the manufacturing process had to figure out how to tool and get ready to manufacture that, and then you put the thing together and you worked out your problems as you go along, much like we do sometimes in our building and roads and bridges. And you see, in terms of your IP continuity or your benefits, you take a step back before you get to the end of the process. In the 1970s, things started to change. You have an assembly line. It's a bit more like the car industry where you're starting to better organise suppliers and the delivery of parts and some components to the process. But your authoritative part of the process was still your drawings. And even in the noughties, I think it was Boeing 777 was the first jet to be fully designed digitally, but the authoritative part of the process was still the drawing. And Miro will tell the story. If anyone wants to know more about this, please call him because he loves to talk about it. In fact, he talks too much about it seriously. But so they went through this process of having the ability to design and do a digital mock-up of a plane, yet in 20 years ago, in fact, about 21 years ago, but still the drawing was king. So they had a lot of time and effort went into just, going between those two mediums, if you like. And that's what I can see that we still do. Go from 3D with the use of tools like Revit, 3D, 2D, 3D, into Tekla, and then back again, et cetera, et cetera. So they needed to resolve this problem of their goal was to completely do it in 3D, and so they needed to resolve the issues of solid modelling, where if an engineer modelled one part, another engineer on another side of the world modelled another part, when they came together, they stuck together, right? So it was probably 2005, and the 787 was the first jet where it was completely 3D. And the benefits were in the millions, because what they were able to do is do the 3D design, but also address the tooling scenario, so that the reductions in cost and tooling were dramatic. And then that last picture there, you see they're actually, work instructions similar. We saw the Aconex type tools. So there was this continual flow. It meant that engineers, while Australia still builds part of the Boeing 787, we build, in fact, I think it's on the next slide, part of the wing. Oh, look at that, didn't know that did that. So we, just up part of that, the wing is built here in Australia, the trailing edge. So it means that engineers globally are in the same Revit tool, and it's real time, and they see the clashes as they go, and they resolve them as they go, all in the same tool in multiple places around the world, and they can actually then, through the design, the leadership design process in Boeing, actually then start to talk about how they can change the design on the fly in completely different companies in completely different parts of the world, because they can see what's going on. I think I've probably spoken about a lot of this. So, and that's what's possible, right? I was doing this 20 years ago. And that's what Frank Gehry figured out. So Frank Gehry was doing this 20 years ago. It's just Dassault that was a bit late to get to that. I hope there's no one from one mothership in the room, actually. They threatened to come. So similarly in the automotive industry, so maybe 3,000 parts in a car, depending on the car. Back in the model, the Henry Ford days, you had to put those 3,000 parts together. Now it's 10 assemblies. So literally, car companies now are assemblers. They're not manufacturers anymore. So their tier one suppliers are next door. So they insist virtually, literally next door. And the interesting thing is what happened during this progress. So counterintuitively, they discovered that quality was better. I mean, maybe it shouldn't be counterintuitive, because you give ownership of the problem to a smaller set of people, and you let them, their ingenuity and their innovation come to the fore. So the other thing that they discovered was there's less joins, right? So it's pretty obvious. So if you're building a building and you're bringing in all the pipes and the fixtures and the fittings and the basins, and you're sticking it all together, there's a lot more joins, there's a lot more rooms for error. So that's been the transformation in the car industry for decades now. They measure success in millimetres. And of course, you've got the benefits of all those things come together, and the time and cost is reduced dramatically. So this is similar. I love this 138 rule of shipbuilding. So if it takes 1 hour to build something in a plant, in a prefabricated plant in a factory, it takes 3 hours to do that on site if you're what they call outside the hull. So if it's a prefabricated type arrangement. Or if you're having to be inside, it's 8 hours. And that's the benefit that they realised. I have actually I'm not an engineer, but I've got a maths degree, so you can see I love the maths. And the theory of joining, which I just spoke about, it's a mathematical formula, and it's exponential. So the more joins you have, the bigger the problem grows. Just a few more points on the aerospace industry. So I realised here I can look at this instead of keep turning my head. So if anyone hasn't seen that book and wants to know more about the transformation that's possible in the AEC industry, of the learnings of the aerospace industry, get that book, because there are a couple of architects that wrote it, and they're much smarter than me, and it's actually a really interesting read, and some of my material has come from that book. I found it quite, I don't read many books, but I usually like to grab ones like this. So before getting into some case studies, I want to talk a bit about this thing called BLM. So I think previous speakers touched on this a bit. BIM is the what, whereas construction is more an activity-centric process. So we see, I'm not sure if we cause coined the phrase, or someone else did, but effectively adding BLM and PLM together, BIM and PLM together. So effectively, what we're talking about is a collaboration platform, which I'm hearing now there's lots of, but it's come out of the automotive and aerospace industry. So what it's designed to do is carry data at the lowest possible level and make that data transactable. It's actually not concerned about what tools everyone uses. It's concerned about the end-to-end process. So take a Rhino data, Revit data, whatever data you want, and put it onto the platform and enable others to access what we call a single version of the truth. So that's what the likes of Boeing uses. So any data you like, you can use standards. So if you're using IFC, which has been mentioned, but it's extensible. So it's extensible. So if you want to track more data than it's available from a model you have, you just build that data into the platform. So I guess the benefit is single version of the truth, real-time data, the RFI process that was spoken about earlier, that can be nailed on the head straight away because you can open up models, you can resolve problems. So I think it's more of what we're going to hear a lot of this conference. So this is the process that we typically see at the moment because of disparate data, effectively, not because we want it to be that way. And this is the process that we'll get to within the realms of having your data inside of I guess a single collaboration platform. Not as easy as it sounds, granted. And the small baby steps is, in my experience of helping companies take on this type of technology in retail and in manufacturing, is there's a way to do it. And you do. We have a saying: think big, start small, and scale fast. And you can do it. And I know there are a number of companies. I think Arup globally. I think BPI in Perth, I believe, a building, trying to build these platforms themselves. Why wouldn't you? Then we add digital mock-up to the process. You can do some quite amazing things because we're talking about from a 3D model that is detailed. So you can start to actually look at the complete workings of a project before you actually start that project. And so what you can even look at ergonomics. So you can start to look at, well, how would it be maintained? How will it be built? I've got a video in a moment that'll extend the story. So this is what we're trying to achieve with BLM, get to an integrated process, have the digital capabilities, etc., etc. And so instead of our disjointed process on the left, we have what we saw in... so I think that's about enough for that bit. See, everyone should be smiling there. See, smiling? It's all good now. So this was the video I was speaking about. So this is part of the tool set that... it's a trick. It's come out of building oil rigs, building factories, building large items like submarines. It's a 4D process simulation capability. So what it actually means is you don't have to have a 3D model. It's better if you do because it's quicker. And you can completely simulate the working model of anything effectively. And in this case, this is a project in China. And the only reason why you can't see lots of little men and women running around and piles of dirt and multiple cranes is because it was removed deliberately because we don't have permission to show that. But this is actually a fully working simulation of determining what's the best option prefab for a project, because it wasn't one building they were building, it was, I can't remember, something like 30 plus buildings. So they wanted to look at, and you can see in the case of the prefab, things have been dropped in then the traditional method. So they modelled four different levels, 30% free prefab through the 90%, and obviously 90% was the fastest. Ben, how much time do we have? Yeah, plenty of time. I tend to rush. But they found that the best value in terms of, cost, price, value was the 70%. things like the cost of delivering things and stockpiling, the cost of labour, the cost of storage is all taken into account. So this is available, and before I die, I want someone to actually use this. And I don't care if they don't buy it. We'll arrange some sort of, project where everyone just pays for the consulting fees, because we need to play with this stuff. I know a few people have seen this case study. This is shop architecture and the building of the Barclay Centre in Brooklyn. So in this case, it's a pretty big project, right? It's not like you're just putting up a 3-storey facade on the side of the road, but it's 11,500 individual 2-metre folded steel panels. Each one is unique, so that had to be modelled. So the shop architecture actually spawned a company, Shop Construction, out of this process. So they used that same platform that we were speaking about that Gehry took on, a newer version of it. So the wireframes were done in Rhino. There was a Revit model, but they couldn't easily get to the fabrication process. So they decided to take on a different approach to that under the guidance of Shop, where that data was taken, and the final conceptual design about how many panels they want and the shape and how they want that to look was done in CATIA effectively, what thing we like to call now the 3D experience platform, pretty fancy name. So that's the process there. So you could continually have design changes and reviews, but effectively after the conceptual design was done, then the actual the engineering rigor, if you like, was then built out in the same platform like they were building a submarine or a jet, because it's got complete parametric modelling, it's got knowledge wear in it, so you could even then change the configuration of the shape of the whole facility, and it would automatically recalibrate itself. And they saved, it's a side view, they saved a significant amount of money. Again, I know this is a pretty complex project. I think that adds up to around about 11,500. So you could take your typical, sections to produce your drawings at anywhere within. So then they had to, produce the folded panel arrangement to cut out. Because it's parametrically designed, it means that instead of spending hours and hours and hours on drawings, once you produce the first one, it automatically produces the rest. It's got a barcode on there so it can link them all together easily in the field. They used the nesting capabilities of CATIA to determine what steel they would, what lengths of steel they would. They saved $750,000 in the cost of steel by using the nesting algorithms to decide how they were going to cut. And that's a picture of the cutting machine. These are some shots from, give you an idea of the size of them. They were tagged with a barcode. They were built in Idaho. It's a couple of hours drive on a truck from Brooklyn. So they whipped up a little app to track, and a BLM platform in the diagram I showed you before is designed to sequence the supply chain too. So you can notice if there's the size of these physical mock-ups when you see the people standing under them. So they couldn't afford to deliver the wrong ones and have them sitting around. So on site, they scanned where they needed to join up to and then compared that to the digital model to make sure that when fabricated that it would all line up in case they needed to alter some of the brackets or the joining mechanisms. And this gives you a feel for the importance of that, because it's a massive beast. So when they came along, they would virtually be able to lift it straight up into place. They saved a lot of time doing that. This one's a bit of a secret. This is, but you can tell by that familiar facade probably who it is. They have an office in Australia. It's an Italian company. So they're taking on already very, very successful, using a lot of tools. I think thousands of licenses of Autodesk and the like. But then really see their next level of productivity gain was to use that data, because like we've heard before, that data was in so many different places. It was just very difficult to manage projects. One of the things that a BLM platform will do, coming from, again, that automotive industry, is it can manage projects, but why would you? Because MS Project's easier, or Primavera, or spreadsheets. But when you bring that data into the platform, it manages a program of projects. So you literally synchronise your project data, and if you're working on 10 projects, it rolls that data up automatically, shows you where your cost overrun is on each project, where your resource constraints are on each project, so you can see it from a program point of view, and that's effectively what these guys are rolling out in the next couple of years. It's a big business. So there'll be more about that later. And SKANSKA has done that already at a back office level. So SKANSKA rolled up, again, connected all their data points within their business such that they could get control of their costs. So when you come to do a new project with a BLM platform, you've got a few options. You can say, where have I done a similar project before? And you just populate all the data and create your project with your work breakdown structures, your resources, all of that, your suppliers. Or you can do it from templates. And so what SKANSKA can do now, they can bid on a project within... well, I'd like to say cents, but within hundreds, thousands of dollars, a major project with extreme accuracy. So they know how low they can go in their bid to win the deal. So they've won more business out of adopting that kind of approach. So what, again, it's not a software pitch, but what Dassault have done is now bundle all this stuff up into applications. So there's a facade application, a structure application, an MEP one coming next year, but this is my favourite. So there's a civil application. So they've got joint development labs with Schmedy in China, because China isn't, they're unencumbered, so they haven't had the years of the development that we have, and really ending up with all these different tools and these different ways of doing things. So they're just going, I've got to build a really big project, I'm just going to go and do it and grab whatever software will make that work, whichever way. So they, I mean, let's face it, half the world's construction is currently in China, so I'm told. Don't quote me on the exact number. So on this rather major bridge project, similar thing to the facade example at Shop. So they grabbed whatever, I couldn't even tell you what initial models they had. I effectively started using CATIA fairly early on the piece. So they, so what happens is they're designing this thing and doing a virtual mock-up of it. They're actually also building out a bill of materials. And so you end up with a complete, much like you do with a jumbo jet, a complete bill of materials and an accurate, super accurate design right down to where all the screws and bolts go. And if you are using some form of collaboration platform, not Dassault's, anyone, then what you can have there is also a number of things: the sequencing of the production, the sequencing of the arrival of everything, and also just the supply, the cost of the materials, and make decisions early on in the process about, you know, whether you use those materials or different materials, etc., etc. So I hope it made some sense, because I think that's the end. Thank you. As long as they're not tricky, as long as they're not engineering related and architecture related, and it's Dominic in the room. Yeah. Well, we need a microphone, I probably won't hear.
Bilal Sukar from Change Agents. I want to ask you about PLM.
Sorry, PLM?
No, you choose.
PLM?
Yep,
okay.
PLM. The marriage of BIM and PLM.
Yeah.
Yep. We know that the efficiencies you can get out of a single product like a ship or a plane is multiplied by using these types of technologies. But when you're looking at the building industry and there's no integrated supply chain, do you see the same benefits, less? And if you see a difference, how do we bridge that gap between the two industries?
Yeah, I absolutely see the same. Oh, well, the first comment I would make is, yeah, you don't seem, it's we now because I'm part of this, we don't seem to have a supply chain, sort of, not like, automotive or it's you know, your subcontractors get involved and then it's kind of, you know, just it's free for all. Look, how we change, it's cultural. I get really frustrated when I go visit an owner who doesn't give a shit. You know, it says, I just pass the wrist down to Grocon or to Leighton's and then I go visit them. They go, oh, don't talk to me. and what happens is people down the line get continually squeezed. So it's cultural, right? It's cultural. And I believe there's a lot of changes going on. There's some really great companies out there already changing, but effectively it's cultural. There's no reason why we can't take on building the next Eureka and do it in half the time and half the cost. And the platform's not the answer. BLM's not the answer. BLM is the enabler. It would take a change in the thought leadership of certain people to go, I want to do this differently. And then you can absolutely do it. And what I see is there's already lots of really smart people that when you start a project are collaborating, they're in rooms, you know, they're coming up with ideas, there's designs, those designs get passed on, someone else does some more designs. Like the brains are there. It takes a change in culture. It takes someone at the beginning to say, I'm going to drive something better quality, more efficient. The software's just an enabler. And we couldn't go and install the software right now to a major client because of the disparate nature of data and people's attitudes. But you pick a small project, that's what you would do. If you talk about the software now, you pick a small project and you get maybe 6 users on it and you do part of it. You get your data right and you learn, and then people look over the fence that was shared before and, I want a piece of that. And that's the way those other industries are. Took Boeing, that was 10 years between having the first 3D model and then having the plane fully built digitally. So that's a 10-year journey. Have anyone, by the way, seen the wing test? The wing test, the Boeing wing test? Google, YouTube, 777 wing test. It's fantastic. So they got in all the engineers, and this is part of the journey where everyone's starting to get on board and they see a better vision and they get excited, right? So you've got all these teams of suppliers and engineers together, and they get this I think they've done it more than once, but say this 777, and they rig it up and they start to bend it up, right, where it shouldn't go. And they get up to, I can't remember, up to like 70% or 80% or something, and the thing just shatters into 1,000 bits. And they all get excited like kids in the lolly shop, right? But the model, the software, predicted exactly where it would shatter. So when someone in Australia is building that bit of a wingtip and someone else is doing some holes in a subsequent piece and arrives at the factory, screw into place. Sorry, I'm carrying on a little bit. Get a bit excited. Lucky Miro's not here. Man, he would just be worse. So yeah, it's possible.